Okay, we're continuing with Chapter 3 of the Statistics textbook on the histogram. In this video, we're going to go through Section 4, Variables. So variables in a histogram. The current population survey covers many other variables besides income. So we're still talking about this population survey in this chapter. A variable is a characteristic which changes from person to person in a study. Interviewers for the survey use a battery of questions. How old are you? How many people are there in your family? What is your family's total income? Are you married? Do you have a job? So a variable changes from person to person. You have the main variable, which is like the title of the survey, what the survey is about, but there could be other variables. A variable is something that's changing between the subjects. So for these different questions, the corresponding variables would be age, family size, family income, marital status, and employment status. Some questions are answered by giving a number, in which case the corresponding variables are quantitative. Age, family size, and family income are examples of quantitative variables. Some questions are answered with a descriptive word or phrase, and the corresponding variables are qualitative. Examples are marital status, so single, married, widowed, divorced, separated, and employment status, employed, unemployed, not in the labor force. So you can think about whenever you're filling out those forms at the doctor's office, if you have to give a number for a question, your age, some of the questions you give a number, that's considered a quantitative variable. And some of the other questions you have to give, it's more of a descriptive phrase, like employed, unemployed, single, married. That's a qualitative variable. Now, furthermore, quantitative variables may be discrete or continuous. This is not a hard and fast distinction, but it is a useful one. For a discrete variable, the values can only differ by fixed amounts. Family size is discrete. Two families can differ in size by 0 or 1 or 2 and so on. Nothing in between is possible. So according to this definition, a discrete variable can differ only by fixed amounts. So for a variable to be discrete, it doesn't mean that it has to be an integer or a whole number. It's just anything it can only differ by fixed amounts. So even if, it can only differ by 1/2. So 1/2, 1, 2.5, 5, 6, 7.5. That would be a discrete variable. So family size is discrete because you can't say 1/2. But age, on the other hand, is a continuous variable because you can say, it's kind of depends on how you look at it, but no one puts on a doctor's office form, I'm 21.5 years old, but you could technically put I'm 21 years in a month old or an hour old. So, but finally, the terms qualitative, quantitative, discrete, and continuous are also used to describe data. Qualitative data are collected on a qualitative variable and so on. So you can have qualitative data, quantitative data, quantitative discrete data. It's just describing the data as a whole. A doctor's office form typically would be both qualitative and quantitative data that's being collected. Okay, so we have variables. Variables are either qualitative or quantitative, and quantitative is further broken down into discrete or continuous. Section 2 showed how to plot a histogram starting with a distribution table. Often the starting point is the raw data, a list of cases, individuals, families, schools, etc., and the corresponding values of the variable, right? The raw data. You've got 5,000 data points, and each point says the amount of income. And that's going to be a continuous variable, continuous quantitative variable, because you could say you don't have to give fixed, like 6,000, 7,000, 8,000. You could give any number theoretically. So you have your list of data points, which would be just individuals for the population survey. I guess you get that person's name and then put their family income, the corresponding values of the variable. In order to draw the histogram, a distribution table must be prepared. You prepare it with the raw data. You count. But the first step is to choose the class intervals. With too many or too few, the histogram will not be informative. There is no rule. It is a matter of judgment or trial and error. Okay, so the number of the class intervals or the size of the class intervals, it's just a matter of judgment, experience, trial and error. It is common to start with 10 or 15 class intervals and work from there. In this book, the class intervals will always be given. When plotting a histogram for a continuous variable, investigators also have to decide on the endpoint convention, what to do with cases that fall right on the boundary. With a discrete variable, there is a convention which gets around the nuisance. Center the class intervals at the possible values. For instance, family size can be 2 or 3 or 4 and so on. The census does not recognize one person as a family. The corresponding class intervals in the distribution table would be, so that's the possible values, right? You can't have, these are the only values that can be answered for family size, right? We're looking at family size as an example. So the class intervals, the center point is the possible value. Since a family cannot have 2.5 members, there is no problem with the endpoints, right? And when you do it this way, there's no issue with the endpoints because you're not going to have any value that's going to fall on an endpoint. Figure 6 shows the histogram for family size. The bars seem to stop at 8. That is because there are so few families with 9 or more people. And so here you go. And so you can make the histogram have a cleaner look to it by you don't put the endpoints. You just put the center values. Okay, so now let's answer the exercise problems. Classify each of the following variables as qualitative or quantitative. If quantitative, as discrete or continuous. Occupation. What is your occupation? That is qualitative. Region of residence. Region of residence. That's qualitative. Weight. That's quantitative, continuous. Right? There's not fixed differences between each answer that are required. Height. Quantitative, continuous. Same idea. Number of automobiles owned. Quantitative, discrete. You can't say I have 1.5 automobiles. Okay, in the March current population survey, women are asked how many children they have. Results are shown below for women aged 25 to 39 by educational level. Is the number of children discrete or continuous? Discrete. It's quantitative discrete. Draw histograms for these data. You may take 5 or more as 5. Very few women have more than 5 children, so just take 5 or more as 5. Okay, so we're going to draw these histograms. There's 2 different histograms that we want to draw because this chart gives, so the women aged 25 to 39 by educational level and number of children. Yeah, so they give us the percent breakdown of the number of children. So this is a distribution table, but there's 2 separate variables. They give us data for 2 separate variables. Women who are high school graduates and women with college degrees. And they've got the percentages already calculated, right? This is a distribution table. So for high school graduates, we'll start with the horizontal axis. And then, so 1, 2, 3, 4, 5. This is number of children. Okay, and we're going to have a bar for 0 as well. No children. Okay, the vertical axis, the width of each of the blocks is 1. Even the 5 or more blocks just can have a width of 1 because we're assuming that there's no families that have more than 5 children. So that means that the height of each block is just going to be the percent. All right, so 5, 10, 15, 20, 25, 30. Yeah, let's do that. So okay, so the 0 block is 30.2. The 1 block is 21.8. The 2 block is 28.4. The 3 block is 13.7. The 4 block is 4.4. And the 5 block is 1.5. Okay, now this is high school graduates. Okay, for women with college degrees, the 0 block is 47.9. The 1 block is 19.4. The 2 block is 22.7. Three block is 8. 4 block 1.5. And the 5 block 0.5. This is college degree. All right, so what do you conclude looking at the histograms? So we can extend this up. So that's more of a direct comparison. And so we're skewed to the left here on the college degrees histogram. So women with college degrees have less children, is what this shows.